Hello, I'm Mr. Troha. We're going to do some astronomy notes on the HR diagram, likely the most important graph in all of astronomy. What does HR stand for? Hertzsprung-Russell diagram. These are named after two guys, last name Hertzsprung and Russell, who developed this in the early 1900s, and it shows the relationships between the temperature of stars and their luminosity, as well as the color or spectral type of stars and their absolute magnitude. Now, here this is kind of interesting. It's not something you see that often, that you have all four sides of a graph here, four different axes in one graph. So they found temperature and spectral class were related, and then absolute magnitude and luminosity were related. So they were able to set this up this way. Notice there's some labels in here. We have our supergiants, our giants main sequence. That's the kind of the normal pattern for stars, and we have white dwarfs down here. So we'll see this a couple different ways throughout the video. So as I said, luminosity, absolute magnitude, effective temperature, and spectral class. Let's talk about these four things. Another HR diagram for you. Again, we have hot white stars on one side. The supergiants up here, very luminous. They're bright. As we go down here, these are dim and cool. So dim stars down here. Have a couple of, here's our sun right here. It's kind of a boring star, but there it is. So as far as luminosity and absolute magnitude, they are related to each other. They're both related to brightness. They're just different ways of measuring it. Luminosity is a measurement of the total energy emitted by the star, and it's measured relative to our sun. So if our sun would be 1 solar unit, or we could determine based on that. Absolute magnitude is how bright a star would be if it was 10 parsecs from our Earth. So that's basically a way of comparing kind of apples to apples. If we put any star or any object at 10 parsecs away, how would they compare in brightness to each other? All right, so interestingly, that absolute magnitude is inverse logarithmic scale. So we do have negative numbers for very bright things, and the high magnitude is actually dim. So it's opposite of what you would think. Our sun is about a 5. Effective temperature. So we talked in a recent video about the fact that temperature is related to the energy of the star. So the effective temperature is the average temperature on the surface of the star, and so those temperatures are related to color. Here's another HR diagram for you, just a different version. So we have our luminosity and our surface temperature. We have our spectral class, which we haven't talked about yet here. So as I said, luminosity is logarithmic. So it's 1 is right here at our sun. That's 1 solar unit. As we go up, this would be 10, 100, 1,000, 10,000, and so on, up to a million. And down here, as we're going 0.1, 0.01, and so forth. So that is our sun. We have, and one thing I like about this is it has specific names of stars: Betelgeuse, Antares, Rigel, Arcturus, Sirius. So they have a number of different things along here, along the main sequence as well. Notice that our temperature is actually a little bit opposite. We have our high temperatures over here in the blue, right? Those are the higher energy, and as they cool down, they move towards red, red being lower energy. Now, spectral class is related to temperature, but more specifically, it's color. Color and temperature kind of combined. So we have O is the hottest. There's letters B, A, F, G, H, or G, K, and M. You'll have to look up another video to figure out why in the world they named them those letters. But this is the hottest to the coolest, and they are associated with temperatures as well as colors of the stars. You can remember those. There's a couple of sayings. Oh, be a fine girl or guy, kiss me. O, B, A, F, G, K, M, or For some others, oh boy, a failing grade kicks me. I'd be very sad at this time. So now, interestingly, these spectral classes can also be subdivided into 9 subclasses, 0 through 9. So you can have B2 or K0. So 0 being the hottest of that class in that subclasses, and 9 being the coolest. So M9 would be the coolest star, O0 would be the hottest. All right, one more shot of the HR diagram. This one you'd have to really zoom in on, but it does provide a lot of information. Here we have luminosity and absolute magnitude. They end up putting them both on the same scale versus on opposite sides, and then spectral class, surface temperature down here on the same scale instead of on opposite sides like the first one. So they do come in all shapes and sizes. Well, maybe not all shapes, they're all rectangle, but they do look a little bit different, and some people like more than the others. All right, thank you for watching about the HR diagram, and have a great week.